This real-world XML algorithm is called hasSibling, and you basically use this one to determine if a node has a sibling node that either has a name of a given type or a specific sibling. That is, a node that exists at the same level as the node we're interested in comparing on either side of it. So let's see how it works. So hasSibling takes two arguments, oNode and oTestNode. So oNode is the one that we're interested in testing against. And oTestNode is either going to be a string, which indicates a type of node that we're interested in finding, or it could be an object, which indicates a specific instance of a node that we're looking for. So, for example, using this function, we can check to see if a paragraph has a sibling of another type, like another paragraph or a div or something. Or we can check to see if a node has a specific sibling in mind. You might want to check to see if a button control has an adjoining edit field, for example. Let's take a look at how it works. We start off declaring a temporary variable that holds the previous sibling of the node that we are looking at. So the first thing we're going to do is search to the left. Then we're going to search to the right if we don't have any matches. So while we have a node to compare against, we check to see if the type of argument that we were given for test node is a string. And if it is, then we compare the node name against the test node. Otherwise, if it's an object, we're looking for a specific instance. In that case, we compare the two objects together and return true if they match. If we don't have a match, then we simply get the previous sibling. And this will eventually become null if we run out of siblings and we have no matches, which will cause oTempNode to be null, and then this while loop will fall through. When that happens, we look the other way. We start looking at next siblings. Now we're going to search to the right, and the whole process starts all over again. Okay, so let's look at this in the code and see how it works. Okay, so here we are in the code, and we need to write the hasSibling function. You can see that I'm using the same example file that I've been using all along. There's the sample XML code up there. So what we're going to do in this example is get a reference to the C tag, which is right here. We're going to check to see if the C tag has a sibling of type E, of type I, and then we're going to see if it has a specific instance of E next to it. So we're going to get a reference to the E tag that's up here and check to see if the C tag is a sibling of it. So you can see that the C tag here is in fact a sibling. It has two of them actually. There's a C, a D, and an E. They're all at the same level. I is all the way over here, so it's not a sibling, so that should return false. And since we're getting the specific instance of E that we compared up here, this one should also return true. So in this case, it says, hey, does my node have a sibling of type E? And this one says, hey, does my node have this specific node as a sibling? So let's go ahead and write the hasSibling function. What we're going to do is declare our temporary variable. And this is going to hold the node that we do our comparing against. And we're going to set it to be the previous sibling to start with. And while we have a temp node to compare against, we're going to do the comparisons. And so if the type of test node that we were given is a string, we're going to do a string comparison. Otherwise, if we were given an object, we're going to do a object comparison. And if no match happens, then we'll just simply get the next node. Okay. And let me close this off right there. And move this up to the right level. All right, now if this does not result in a search match, then we start on the other side looking at next siblings. So in that case, we're going to set temp node equal to onode.next sibling. And in this case, the logic of the top half just repeats again. So I'll copy that, paste it down here. And in this case, we're not looking for the previous sibling anymore. We're looking for the next sibling. And in the case of strings, we're going to compare the temp name. So if temp node.node name is equal to test node, then return true. And in the case of objects, we're not comparing the node name, it's just the object itself. And the same thing down in the next sibling case. So I'll just copy and paste those guys. And if this while loop falls through the bottom, then we just need to return false. Looks like we're ready to give this a spin. Let's go ahead and bring this up in the browser. So remember, we're looking for true, false, and true. There's true, there's false, and there's true. Let's try it with Firefox. There's true, false, and true. Now you know how to check to see if a node has a sibling of a given type or a specific instance. So now we're going to move on to our last example.